Hello and welcome to my final project, Faraday's Law with Electric Motors for Physics 230. My name is Eli Barrientos. Today we're going to go through an abstract introduction to physical principles and electric motors. Here I wanted to start out with a quote from Michael Faraday. The beauty of electricity or of any other forces is not that the power is mysterious and unexpected, touching every sense at unawares in a turn, but that it is under law and that the taught intellect can even now govern it largely. My abstract listed here is to link the electric currents and magnetic fields as described by Faraday's law and a key idea of electromagnetism. To note, the changing magnetic field causes an electromotive force, which is known as EMF, or the voltage to be induced in a coil of wire, which produces an electric current that can move the motor. In section 2, our introduction, we're going to illustrate the electromagnetic induction according to Faraday's law in a Tesla motor car's electric motor. And section 3, physical principles. Here I've listed out a little bit more detailed text that you can go over, and I can forward out this slide deck after the presentation. But I did want to highlight here this red arrow of rotation going clockwise demonstrates how a motor then works under Faraday's law. Here you can see the cylinder will turn, and attached here are magnets that are rotating over these coils. And that there would produce the force here and then translate out to mechanical force. And in addition to that, you have a flow of current that is produced in voltage that can then power it even more. Here I've listed out Faraday's law, but I wanted to highlight Faraday's law and relativity, the two phenomena. Um, Faraday's law is a single equation describing two different phenomena: the motion of EMF generated by the magnetic force on a moving wire, and the transformer of EMF generated by the electric force due to changing magnetic field. Here I have highlighted a Tesla Model S. You can see the battery inlaid on the floor, and then also here in this section by the front wheel on the right side, looks like, is the motor. The node is Maxwell Faraday's equation. The equation is also known as Faraday's law of electromagnetic induction. This is formulated by James Clerk Maxwell, and here you can see it stated mathematically, and to note that it describes the relationship between a changing magnetic field and the induction of EMF, or the voltage, in a closed loop of wire. Section 4 is over electric motors, and it details the small-scale motor model that depicts the interaction between the magnetic field and electric current, used to illustrate how Faraday's law is used in a Tesla's electromotor. Here, when you perform this experiment, things to highlight is to, um, here it notes the wrapping of the coil multiple times. I'd say at minimum 20 times. It sounds like a lot, but it actually will produce the desired effect more so. So, good tip there. Remember to remove the enamel from the insulation wire ends. That's going to help with connection. And the support section is to make sure that you use a piece of cardboard. That's going to kind of make everything stable for the experiment. Again, hot glue and the cardboard to make sure it's stable. Magnets to make sure that they're placed around the coil to produce a magnetic field. These magnets you can find on Amazon. I found them for like $5 and I got like 20 of them. Very strong and it's a cool effect. Make sure your connections on the coil and the battery are secure and clean. And then lastly, once you get that all set up, you can watch the magnetic field and the electric current interact to cause the coil to start rotating. This process shows how a Tesla motor applies Faraday's law of electromagnetic induction. Rotates as a result of the interaction between electric current running through the coil and the magnetic field produced by magnets. The same concept is used true in a Tesla electric motor. To go over some feedback that I had adjusted, Here, slide 4, let's jump to that. The abstract was reduced. There was much more text here, and I think taking the feedback and reducing that helped with the overall presentation. And also slide 7 was the same. There is pretty text heavy, but I wanted this to be a reference point that everybody had the information needed when the slide deck was presented back to everybody. Let's jump to the feedback. And overall, the text had been reduced throughout the slide deck to make sure that it was under time. And um, the other thing is to note that when we make a PDF file of this, or even in the presentation, my speaker notes are not shown. I will just drop this over. If I jump to slide 7, you can see that then it is listed there. So that's a little note about that. Thank you, everybody. Here's my email. If you wanted a slide deck, I can forward that out. Just give me a ping on the reply. And just to give credit to SlidesGo for the great slides that we have here, flat icon, free pick, and just my quoted references that can be clickable here when I distribute the slide deck. And they are from Wiki and Tuition Physics. So thanks to them. Thank you so much, everybody. Have a great semester.